React, a library which seems relatively simple at first glance, but the deeper you dive into it, the more complex it gets. What starts off as clean and manageable code quickly turns into an unmanageable nightmare riddled with performance and security issues. The truth is, your codebase is probably full of these issues and you probably don't even know it. But don't worry, in this free video I will show you first of all what issues you have in your codebase probably, and of course how to fix them. So now, without any further ado, let's roll the video. Let's go! Alright, let's get started with issue number 1, and this deals with state. What do I mean with that? Well, right here I have created a little example. This is something like an e-commerce page. This means you can first of all select a category. So for example, clothing. You can search for something, like for example an iPhone, and we have pagination. Now my question to you, how would you implement something like this? Well, most of you would probably use state, and that's not actually bad. So most of you would use state, then you would create 3 states. First of all for your actual category, then for your pagination, and then for your search. Then right here, for example, I have created one simple function. We use the filter method. First of all, we see or we check that the category matches our product category. We have our dummy products with our category, and we see that the category matches the product category. Then we do our searching. This means we check if the name of the product includes our search query, and then at the end we do pagination. And as you see, everything works. So searching works, pagination works, categories work, and the code itself also works. There's no problem with the code itself. The problem is with client-side state. Because the thing is, client-side state is temporary and it's actually kinda bound to your user session. If you do a hard refresh, your state is lost. So let's search right here for iPhone, for example. And now, as an example, you copy the URL and you want to send it to a friend. Your friend opens this URL in his browser and then there's no state. The user or your friend does not see the iPhone, and that's the problem with client-side state. And now the question comes, how can we fix this problem? Well, it's relatively simple. Instead of using client-side state, let's rather use URL state. This means right here, if I search for example for iPhone, my URL updates. So right here you see it's now question mark search and then iPhone. If I for example click on clothing, we have question mark clothing. And if I, for example, delete everything again and go to next page, we have question mark page 2. And this means if I copy the URL and send it to a friend, everything is still persisted. And the code for this is actually relatively simple. So I use the useSearchParams hook. This is provided by Next.js, and this allows me to get the query right here, so the query parameter. But if you use React Router, the hook should be called the same. And what I do is get my search param. So first of all for the category, then for my actual page, and then for my search. Then we have our update params function. This is there to update our params. So whenever we select something, we want to put that in our URL, and then we have our products function again to just get our products itself. This is the filter method. So you see the code is actually almost the same, but you have a lot more benefits because everything is still persisted. So in my opinion, you should always use URL state whenever you want data to persist across page loads. This means when you, for example, send a website to a friend, and this is very common when you use e-commerce websites, you always want to have persisted state. And one thing which I want to also mention quickly right here is if you have something very complex, this means if you have a very complex application which needs complex URL state management, then I would recommend this library which is called Nux or Nux. I'm not sure how you pronounce it, but this will make your life way simpler. This means if you have a simple application, just use the native hooks. So for example, use search params. But if you build something very, very complex, then maybe a third-party library could make your life a bit simpler. Let's now continue with issue number 2. And this issue deals with packages. What do I mean with that? Well, raise your hand if you have ever installed a package without even checking if the package is actively maintained, safe to use, and actually viable for your project. Here's the thing, React evolves very fast. This means we have React 17, 18, 19, soon probably 20. Everything adapts very quickly. But packages have to also be maintained and updated to at the end of the day work with the new React versions. And you can really quickly run into bugs, issues, security issues if these packages are not maintained correctly. So I just mentioned a few moments ago that Nux is is a great library if you have a complex project and if you need URL state. But most of you will probably not check if the package is maintained actively. So in this example, Nux is actually maintained actively. As you see, it has a lot of stars, a lot of people use it, we have a lot of weekly downloads. The code itself is safe, I have looked at the code, but at the end of the day, most of you don't do that. And that's a big security issue, because there are things like, for example, package hijacking, where people hijack packages and then add malicious code, which you install and then render to your users. So here's my recommendation to you. Packages should always be viewed like a third-party source, let's call it like that. This means you want to always verify that everything is safe and actively maintained. Also, as mentioned, it should be viewed as something third-party, meaning you should limit the amount of use. Let's now continue with issue number 3, and this issue deals with React keys. And before I even explain anything, let's look at this example. So this is pretty much a to-do list application. You can create a new to-do, you can move a to-do to the top, and you can delete it. So let's create a new to-do. Hello. Let's add the to-do. Then let's add another one, and let's say this is a test. Let's add it right here. So now we have our items right here. Everything looks fine. Or doesn't it? Well, right here we say this is a test. Hello, learn React, share with others, share with others. But this is incorrect, because if I refresh this again, this was build something cool, share with others. Why did we just have share with others 2 times? Let me show you another example. Let's again add 2 items. So let's say hello, and let's say also yo. What I'll do now is click on move on top. Then let's move share with others on top. Now we have built something cool. Let me click on yo, and let's say move to top. We have yo. Let's now click on build something cool. Okay, we have it right here. Let's click on share with others. Now we have hello. What the hell is going on? Why does this not work as expected? Well, let's look at the code. So we have a use state hook right here with a initial state. So these are our 3 items: learn React, build something cool, and share with others. Nothing groundbreaking, right? So where exactly does the problem happen right here? Well, the problem happens in our mapping. So we map over our to-dos, and for the key we pass a index. And the index is the array length pretty much. This means if we have 3 items, we have the key of 0, 1, and 2. And whenever we change the items, a lot of things go wrong. And you know what? Let me show it to you with a little diagram, or graph if you want to call it like that. So right here we have an array with 3 items. And as mentioned, when you use a key, you use the index of the array. And since JavaScript is 0 indexed, we have the ID of 0, 1, and 2. This means John has an ID of 0, Fisher an ID of 1, and Mark an ID of 2. Okay, I think you understand that. But what happens if I now add a new item at the front of our array? New friend. Now our whole array updates, and with that also the IDs, because we use the index of the array. Now new friend has an ID of 0, John an ID of 1, Fisher of 2, and Mark of 3. But John should have an ID of 0, and Fisher an ID of 1, and Mark should have an ID of 2. And that's the whole problem if you use an index as the key in React, because React uses the key to identify what it should update and what not. So React uses a differential algorithm, and with that again they know what should update and what not. So the differential algorithm first of all checks, hey, what has been added, what can I mount, or in other words render again in the DOM, and what has stayed the same, what can I just re-render. But if you don't have unique keys, this does not work, because in this example now React has to unmount everything and mount everything again. This means it takes all of the items, it throws them out of the screen, takes again the new ones and renders them again. So you see you have to unmount them and then again re-render them, or in other words mount them, and this is quite bad for first of all optimization, but your whole state is also lost because your items don't have unique keys. And now let's imagine for our items we use unique keys. This means for John we have an ID of J, for Fisher F, and for Mark M. Everything is fine. Let's now again add a new item to the start of our array, new friend, and this new friend has an ID of n. What will happen is that React will run this differential algorithm and it will see, hey, we have a new item added. This means I can mount something new. It will take the new friend and it will create a new render. But John, Fisher, and Mark haven't updated. The IDs are the same. This means what React will do is re-render them, because the position has changed, but the ID is the same. This This means we don't have this whole unmount, remount, we just have a new mount and a new re-render. And this also means state is not lost because the ID stays the same. And maybe also you ask yourself why the state exactly changes right here, so the text. That's because it's an input with a default value. So where do we have it? We have right here the input, default value, and this is state. If I would use an p tag and just say hello, then these items wouldn't update. They would stay persisted. But since we use an input with a default value, which at the end of the day is state, it shows you how it loses state. So that's a big problem. So how can we fix this? Well, we can fix it by using unique values, unique IDs, as you saw in our graph. So in this example, I now use unique IDs, and you will now see everything works as you expect. This means let's add a new item, hello, let's add it right here. Then let's say yo, let's also add it. And now you'll see if I click on move to top, everything works as expected. If I delete everything, everything works. No items change, no state is lost, and also performance is as you would expect. There are no major re-renders, on-mounts, remounts, only the things that really have to update will update. And here's also a code example on how I achieved this. So first of all, our initial values have an ID of 1, 2, and 3. And then when I add a new item, I also pass an ID of math.random.toString. This means each new value also has a unique ID, which does not change. And then when I map over my items, I pass a key of todo.id. So not the index anymore, but the actual unique value. And now our application works as expected, it's fast, and that's what we want. Let's now continue with issue number 4. And this issue deals with accessing state after it has been updated. What do I mean with that? So in this example, I have created a little counter. If I click on the button, I want a number to update. So 0, 1, 2, 3, 4. This means if I click on the button, we have count 1, count 1, but console logged and API received is 0. Let me again click on count. Now we have count 2, but console logged is 1 and API received is 1. Why is that? Well, let me show you the example. So this is our page. So we have our export default function. This does not matter. Let's look at the core problem. So we have right here 3 use state hooks. First of all, for our count, the count is what you see in this button. Then we have our state for the API value. This is this one right here, API received. And then we have a state for log value. And this is for our console logged. And then we also have a function. And this is handle clicked bad. And inside of here, you see we do a set count and then count plus 1. This means we take our initial value of 1 and we add another number, 1. So we will have 2. Quite standard, right? And then we console log it. So we console log our count. And then for our console log and our API, we just set our new value with count. And again, we just updated count, right? This means count should now be 2 and not 1 anymore. At least that's what a lot of people would assume. But this is not true, because at the end of the day, state is asynchronous. It isn't synchronous. So even though you updated your count state right here, it does not update immediately because it's asynchronous. And you can also see it in your console. Let me again click on count. What do we have right here? Count is now 0. Again, if you go to the code base, we do a console log, count is now count. But we just updated count, but it still logs the old value. Again, because this whole procedure is asynchronous. So how can we fix this problem? Well, instead of console logging our count, we can instead create a new constant, new value. And then we will use this new value to update all of our states. So now instead of console logging our count, we will console log our new value, because our new value is synchronous. We just calculated previous plus 1. This means we now have 2, and then we just console log it or add it wherever we need. We don't have any asynchronous operations anymore. This means if I now go back and click on the correct approach and click on count, we now have count is 1. And we also have console log 1 and API received 1. Let's again click on it and again and again. You see everything works as expected. Everything is synchronous, and that's what we wanted. So the correct approach is to create a new constant and then just use it wherever you need to always get your new value. Let's now continue with issue number 5. And this issue deals with business logic in your components. What do I mean with that? So let's imagine you build a blog SaaS. This means users can sign up to your SaaS and create blog articles. Now, how would you create something like that? Well, you would create pricing tiers. You would have a free user, a basic user, and a premium user. And this means a free user, for example, can create 3 blog articles, a basic user can create 5 articles, and a user who subscribed to the premium plan can create infinite blog articles. So this is relatively standard practice. And what's exactly the problem right here? Well, we embed business logic in our component. This means inside of this component, I check what plan the user has, and then I return the amount of blog articles the user can generate. And at first glance, this does not look like a big problem. And it isn't, to be honest, at this moment. But let's imagine in 1 year time, you want to update your pricing tiers and you want to say, hey, a free user can only create 1 article. So you just update it, right? Not a big problem. But what is if your project becomes huge and you have to do these checks in multiple places? Well, then you have to go to your search and then search, hey, where do we have our if user.plan and where is it equal to free? And then let's update it from there. Don't you see the problem right here? You have to go in each file and update it everywhere. And then you will make a mistake in one file and say, hey, the free user in this file is allowed to create unlimited requests. And then in the other one, the user is only allowed to create 1 request. And this is a big issue. So how can we prevent that? Or in other words, how can we fix this? Well, it's relatively simple. How about we create 1 constant and let's maybe also do an export constant, and then we reuse this constant wherever we need. Also, often you name this variable uppercase, so for example, plan limits, and then you use it wherever you have to. So now instead of doing this if check or this function get article limit, we now have our constant article limit and we use this constant plan limits. And this plan limits is a single source of truth. This means if I update right here 5, so a free user is now allowed to create 5 articles, this updates everywhere because we have a single source of truth. And that's what you always want to do. You don't want to have multiple points of truth. You want to have 1 single point of truth and then use it from there. And as you also just saw, I created a constant in this file. This is probably something which I would not do because it's hard to find this file. So what I would rather do is store everything either in the environment variable or in the env file. So we would create multiple environment variables and then use them wherever we need to. So we would have our free limit, our basic limit, and then our premium limit. And then instead of using this, we could, for example, get our values from our env file. This is one solution which you could do. Or what you could also do is create a new file, for example, in your utils folder. And then in the utils folder, you would call it, for example, plan_limits.ts. And then you could also store it inside of here. At the end of the day, it does not really matter. It's personal choice. I personally like to store everything in my env file. This means my business logic, and then reference it from there. But I also saw a lot of people who created a file in the utils folder and stored everything inside of there. This is your personal choice. I personally like the env file, but if you want to create 1 file and store everything inside of there, then this is also totally acceptable. Let's now continue with issue number 6, and this issue deals with over-configuring components with props. This is a mistake which you can make relatively quickly because you probably think that this is a best practice. So a lot of people think, hey, instead of creating a lot of smaller components, let's create 1 component, and this 1 component will do everything. And the benefit is it's reusable. Great, right? No, it isn't. So right here we have a button component. And as you see, this button has a lot of properties. The text, the size, the color variant, is loading, width, height, a text transform. So you see we have a lot of properties, and as you see, this looks relatively confusing, and it is confusing, and that's a big problem. A lot of people think it's a best practice to create 1 big component with a lot of properties and then reuse it in multiple places. But this is not true. This is a big mistake, because when a component is over configured, it becomes hard to maintain. So instead of creating 1 super flexible and big component, you should instead create multiple small components which are relatively easy to manage. So for example, now we have 3 components for our base button, secondary button, and then our icon button. You see how simple the code looks? It isn't confusing anymore. And that's what I will recommend to you. Don't create one big component with over-configured props. Create multiple smaller components which deal with a specific use case. Sure, maybe it isn't as reusable, but it's cleaner and more maintainable. And one question which I often get is, hey Jan, when should I create a component and when not? When should I just use the standard file? Well, at the end of the day, there's a fine balance between standard components and over-engineering. So in my opinion, you should work on a single file as long it's easy to manage. As soon as it becomes bloated, then you should create separate components. And of course, if there's some sort of logic which you can reuse, then you should also break it into a component. But you shouldn't break everything into a component. If it's manageable, leave it in one file. If it's unmanageable, break it into a separate component. If it's reusable, break it into a separate component. If the component becomes over-engineered, break it into more smaller components, as you see right here. Let's now continue with issue number 7, and this issue deals with falsy values in JSX. So let's look at this code example. We have a constant items which is equal to an empty array. Then we have our export default function, and inside of here we do a logical AND. This means we see or we check if items.length is bigger than 0. So what we want to say right here is, hey, if items.length is bigger than 0, this means if we at least have one item, then let's map over our items and render them. If not, then let's just short circuit and let's render nothing. This means if this is false, this whole expression will short circuit. This is the correct name for that. And if it short circuits, then it will render nothing. That's at least what you probably think. Because if you save this and go back, you will see 0 and 0. Why is that? Well, first of all, right here we have our items.length check. We render a 0 right here. And then at the bottom, I also do again a items.length check. And items.length is an empty array as mentioned. And a empty array at the end of the day is 0, right? Because you don't have any items. And this is a falsy value. So JavaScript has in total 6 falsy values. First of all, you have your standard boolean, false, then 0, empty string, null, undefined, and not a number. All of these values will provide in false. This means if false, it will not console log it. If empty string, it will not console log it. This will not run because all of these expressions at the end of the day equate to false. But false is the only true boolean. All of the other values are falsy values. And that's also what I say right here. In JavaScript, a falsy value is a value that evaluates to false when used in a boolean context. This means in a if statement or something like a conditional expression. And that's what we have right here. We have our logical AND, and this is our conditional expression. And since this equates to false, we at the end of the day render what we have right here. And items.length is the only value that at the end of the day renders a number because it renders 0. Yeah, like this. And that's why you have these double zeros. So how can you fix such a problem? Well, at the end of the day, instead of doing this logical AND, it's better to do an explicit boolean check. So to check explicitly if it's 0, or in other words, if it's bigger than 0. Because this now equates always to a boolean. This means either true or false. There isn't a falsy value anymore. And that's what you want to always do. So falsy values are a thing which you should know about in JavaScript. Sometimes it will confuse you because you'll see a 0 in your website and you don't know why there's a 0. This is because JavaScript has falsy values, which sometimes render something which you don't want. Let's now continue with issue number 8, something like that. So this mistake is not always, let's say, crucial. This means it won't really break your code, it won't make it slower, but at some point, if you overuse it, it will break your code. So right here you see we have a lot of div elements. So div, way too many divs. You don't want that. Why shouldn't you use that many divs? Well, first of all, it's bad for SEO. At the end of the day, the bot which indexes your website does not know what this div does. Is this div for the nav bar? Is this div for the sidebar? Is this div for the hero? What exactly do we do right here? The bot does not know. The bot is dumb, to be honest. Secondly, too many diffs make your application kinda slow. Why does it make it slow? Well, at the end of the day, React has to render all of these diffs in the DOM tree. And if you have a lot of diffs, well, at the end of the day, it takes more memory and more CPU usage, which means your application gets slower. And what is if you have to re-render everything? Then you have to re-render all of these diffs again. This is way too intensive. You don't want that. So how can you fix that? Well, it's relatively simple. First of all, limit the amount of diffs. You don't want to use too many diffs. Secondly, use semantic HTML. So right here, I now use an article, a header, a section. And with the semantic HTML, a bot, like for example the Google index bot, will know what this website does, or in other words, how this website looks like, because it knows, okay, this is an article, this is a header, and this is a section. So this is way better for SEO, and this is also, of course, better for performance, because now you only have a few elements. You don't have 10 div elements. So to summarize it, it's fine to use div elements. It won't break your code. It's fine to use 1, 2, 3, 4 divs. It's fine, you can do that. But don't overuse it. Don't create 100 div elements and then just write your code. Limit the amount. A suggestion for me is, if you have to use a div, use it. If you can use something else like semantic HTML, then rather do that. And one thing which I also mention right here is you can also use fragments or empty tags. That's how I like to call them. These empty tags don't show up in the DOM. This means you don't overload your DOM tree, and this makes rendering a bit faster. Alright everyone, we're now finished with this video. I hope you could learn a lot. We looked at a lot of mistakes that you probably make in your code base and how to fix them. As you see, fixing it is relatively simple, but the issues itself can break your code relatively quickly. So yeah, I hope you enjoy your day. I hope you liked and subscribed. This would mean a lot to my heart, so please do it. And now, enjoy your day. I hope I can see you in the next video on this channel. So yeah, bye! Whew. Alright friends, what time do we have? We have, what is it here? 13 or 1 p.m. Whew, we are finished. Yeah, enjoy your day. Don't forget to like and subscribe. It would mean so much to me. And if you saw this end section, then just write it in the comment. Write hashtag I stayed to the end or something like that. Okay, bye.